welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your computer-based numerical and statistical technique, which has been the CBNST, and this has been the classes 36 class which we have to cover up. And here in that we had done your 35 classes in the last session. Here we had started with unit 1, and even though we had end up with unit 1, which is computer arithmetic roots or error roots of equation as well, and we had started with unit 2, which has been the interpolations and curve fitting, which we have to cover up here. So before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe to our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. So we go ahead for this question here, where we have to find the cubic spline for the following data. Find the cubic spline for the following data. You have to estimate y at x equals to 4. Okay, so we made a table here. X, which is y equals to fx, 3.0, 4.5, 7.0, 9.0, 2.5, 1.0, 2.5 and 0.75. This is a here we have to estimate y at x equals to 4. So for the same, we'll rewrite the table. We'll just made it here only, that this will be the x I y I upon fx I. So this has been x1, x y1, x2, y2. This is x3, y3. This is x4, and this is y4. Okay, so for the same, here you have to observe that where the h is equals to, that is been x2 minus x1, that does not equals to x3 minus x2. That is why that the data points that are not equally spaced, and hence we have to use generalized equations of the cubic spline given by the equation 5 and the equation 6, and you have to consider this. So for the same, xi plus 1 minus xi f double dash xy plus 2xi plus 2 minus xi f double dash xi plus 1 plus xi plus 2 minus xi plus 1 f double dash xi plus 2, which is equals to 6 upon xi plus 2 minus xi plus 1 f xi plus 2 minus f xi plus 1 minus 6 xi plus 1 minus xi, which is mean f xi plus 1 minus fxi that we have. So here in the above equation, I varies from 1 to n minus 2, and in this example we have 4 data points where n equals to 2, and therefore the I equal will vary from 1 to 4, and minus 2 to, that is your 2 here. So we go ahead for the same. For the same we go ahead and that we talk about it, and for I equals to 1 for the equation, so we go x2 minus x1 f double dash x1 plus 2 x3 minus x1 f double dash x2 plus x3 minus x2 f double dash x3 which is equals to 6 upon x3 minus x2 fx3 minus fx2 minus 6 upon x2 minus x1 fx2 minus fx1. Similarly with I equals to 2, and for the same we go x3 minus x2 f double dash x2 plus 2 x4 minus x2 f double dash x3 plus x4 minus x3 f double dash x4 equals to 6 upon x4 minus x3 fx4 minus fx3 minus 6 upon x3 minus x2 fx3 minus fx2. So here for in the above two equations that we have y1 equals to fx1 and that is being equals to 2.5, and y2 is equals to fx2 which is equals to 1, and y3 is equals to fx3 which is equals to 2.5, y4 equals to fx4 0.75, and you have to put the values for the x and y, and that we get the following equation after this simplification as well, what that they had given you the values as well. So we'll put the value and that will find it out for the same, and that is being the important one. So we go ahead for 1.5 f double dash x1 plus 8 f double dash x2 plus 2.5 f double dash x3 equals to 9.6, 2.5 f double dash x2 plus 9 f double dash x2 plus 2 f double dash x4 equals to minus 8.85. For natural cubic spline, f double dash x1 is equals to 0 and f double dash x4 equals to 0, and hence the above equation will become 8 f double dash x2 plus 2.5 f double dash x3 equals to 9.6, and 2.5 f double dash x2 plus 9 f double dash x3 equals to minus 8.85. Solving above the two equations for f double dash x2 and f double dash x3, we get here f double dash x2 equals to 1.65 and f double dash x3 equals to minus 1.442. So the cubic spline that are given by the equations that will form, which will be here in the form f I x equals to f double dash xy x plus x minus xi plus 1 cube plus whole upon 6 xi minus xi plus 1 f double dash xi plus 1 and x minus xi का cube upon 6 xi plus 1 minus xi plus fxi plus 1 upon xi plus 1 minus xi minus f double dash xi plus 1 xi plus 1 minus xi upon 6 whole x minus xi plus fxi upon xi minus xi plus 1 minus f double dash xi and xi minus xi plus 1 whole upon 6, which is x minus xi plus 1. So in this equation that I varies from 1 to n minus 1, and here n equals to 4, and hence I will vary from 1 to 3 with I equals to 1 with the above equation that will become here. And so we formed here f I x equals to f double dash xi, which is being the x1 x minus x2 cube plus f double dash x2 x minus x2 का cube upon 6 x2 minus x1, and this is upon 6 x1 minus x2, so plus f x2 upon x2 minus x1 minus f double dash x2 x2 minus x1 upon 6 x minus x1 plus f x1 upon x1 minus x2 minus f double dash x1 and x1 minus x2 this is 6 whole upon x minus x2. So we are for that putting the for x and y, that is fx and f double dash in the above equation, we got the simplified equation, that is f double dash x1 equals to 0, and for the same we go ahead and that we have as follows. So on the same phase we talk about that we have here f1x equals to 0.183 x minus 3 का cube plus 0.254 x minus 3 minus 1.667 x minus 4.5. So similarly we'll put r equals to 2, so we get f2x equals to f double dash x2 x minus x3 का cube plus 1 6 x2 minus x3, which is being f double dash x3 x minus x2 का cube upon 6 x3 minus x2 plus fx3 upon x3 minus x2 minus f double dash x3 x3 minus x2 upon 6 x minus x2 plus fx2 upon x2 minus x3 minus f double dash x2 x2 minus x3 upon 6, that being multiplied x minus x3. So putting the x y that is your fx and f double dash x in the above equation, we get simplified the equation as to be follows, which is being f2x equals to minus 0.11 x minus 7 का cube plus 0.096 x minus 4.5 का cube plus 1.6 x minus 4.5 plus 0.287 x minus 7 here. So similarly we'll put I equals to 3 and we get here, so f3x equals to f double dash x3 x minus x4 का cube upon 6 x3 minus x4 plus f double dash x4 x minus x3 cube upon 6 x4 minus x3 plus fx4 x4 minus x3 minus f double dash x4 minus x3 upon 6 x minus x3 plus fx3 upon x3 minus x4 minus f double dash x3 minus x4 upon 6, that is being x minus x4. So for that, putting for fx and f double dash x and f double dash x4, which is equals to 0 in the above equation 2, after the simplification we get here f3x equals to 0.12 x minus 9 ka cube 0.375 x minus 7 minus 1.73 x minus 9. Thus we obtain the 3 cubic spline for the 3 intervals that is will be given in the following way, and that what we'll have to talk about it. So we made a table for intervals and spline. This has been spline. We have intervals. For that intervals we have x1 comma x2, x2 comma x3 and x3 comma x4. So for that splines we have is f1x equals to 0.183 x minus 3 ka cube plus 0.254 x minus 3 minus 1.667 x minus 4.5. For this it is f2x equals to minus 0.11 x minus 7 ka cube minus 0.096 x minus 4.5 ka cube minus 1.6 x minus 4.5 and plus 0.287 x minus 7. This is f3x equals to 0.12 x minus 9 ka cube plus 0.375 x minus 7 minus 1.73 x minus 9. So that we have, and even though which we have to talk about it, that has been the important one as well. So here to estimate y at x equals to 4, here observe that y equals to 4 that lies in the first intervals of x1 x2 and that is 3 comma 4.5, and hence we will be using the f1x to calculate the interpolated value. Y equals to f1 4 equals to f1x. So 0.183 4 minus 3 ka cube plus 0.254 4 minus 3 minus 1.667 4 minus 4.5 will give you 1.27. So y equals to f of 4, which is equals to 1.27, that we get as an answer here. Now we go ahead further, which we'll talk about it, and that has been the another one. The question is, explain the piecewise linear interpolation technique that we have to discuss here. So we go ahead. Piecewise linear interpolation technique. So in the piecewise linear interpolation technique, that the total interval is subdivided into the small subintervals that is consisting of only the 2 data points, and a linear polynomial is interpolated for these 2 data points The technique is called piecewise linear interpolation, and that using the Lagrange's technique, the linear interpolating polynomials that passing through the two data points, which is xi and fxi and xi minus 1, fxi minus 1, we have pi of x equals to x minus xi upon xi minus 1 minus xi fxi minus 1 plus x minus xi minus 1 upon xi minus 1 fxi. So that shows the linearly interpolated polynomials in the various subintervals, and these polynomials are p1x, p2x, p3x and p4x, and that the intervals for the above polynomials are x0, x1, x1, x2, x2, x3 and x3, x4 for the respectively, and that as we will be drawing for the same here. And for the following data points, we will determine the piecewise linear interpolating polynomials as well. We'll do the sub question as well to solve it out and to get the answers here. So for the following data points, determine piecewise linear interpolating polynomials. So we go. This is x and this is fx. x0 is equals to 1 and fx0 is equals to 3. x1 equals to 2, fx1 equals to 7. For that, and that is mean x3 equals to 8, fx3 equals to 73. Okay, so we go ahead by the piecewise interpolation formula for the interval x0 and x1. 1x equals to x minus x1 upon x1 minus x0 into fx1, which is equals to x minus 2 upon 1 minus 2, 3 plus x minus 1 upon 2 minus 1, 7. So equals to minus 3 x minus 2 plus 7 x minus 1, which is equals to 4x minus 1. So for interval x1 x2, we have p2x equals to x minus x2 upon x1 minus x2. So fx1 plus x minus x1 upon x2 minus x1, fx2. So for the same we have, so for the same it will be x minus 4 upon x2 minus 4, 7 plus x minus 2 upon 4 minus 2, 21 minus 7 by 2 x minus 4 plus 21 by 2 x minus 2, and that is being equals to 7x minus 7. For interval x2 x3, fx3 x minus 8 upon 4 minus 8 x minus 4 upon 8 minus 4 minus 21 upon 4 x minus 8 plus 73 upon 4 x minus 4. So for the same 13x minus 31 that we have to find out. So for the same we go ahead and that will discuss rest of the questions, explain gram schematics, orthogonizing process to obtain the orthogonal polynomial that we'll discuss in the next coming class. So here we're going to end up with CBNST, and other than this we had done your sociology and software engineering, even though we had done your chemistry part 1 for class 11th and part 1 for class 12th as well, which is in the unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9 with their conversions as well. We had done your ER diagram, we are dealing with English vocabulary, we are dealing with PHP interview questions as well. We'll surely be starting with physics part 2-1 for class. We'll have to start with physics part 2, and that part 1 for NCRT for that has been for class 11th, and part 2 for chemistry for class 11th as well, that to complete the NCRT part. And after that we're talking about it, we have to start many more. We are dealing with, we had done your reasoning, in that we had done general mental ability in the logic reasoning. In non-verbal reasoning we had done series analogy, classification, analytical reasoning, mirror image, model image, embedded figure, conditions of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dice, dot situation, constructions of squares and triangles, figure formation analysis, practice question set, and that's what we have to deal with it. Coming towards your quantitative aptitude, in that we had done started with arithmetical ability, in that we had done operations on numbers, safe and unsafe of numbers, decimal fractions, simplification, square roots and cube roots, problems on numbers, problems on ages, surds and indices, percentage, and profit and loss. That has been the 11th topic we are dealing here. In the same case, we talk about the computer-based numerical and statistical technique, where we had started with unit 1. In that we had completed your computer arithmetic errors, in that floating point arithmetic, machine abscon, round-off errors, chopping errors, truncations error, associative and distributive law of the floating point arithmetic, inherent error, error propagation, numerical instability. In rules of equation we had done second method, Newton-Raphson method, fixed point iteration method for simple rules and derivation of the rate of the convergence, static and acceleration of convergence, modified Newton-Raphson method for the multiple rules, Birch-White method for polynomial, Weierstrass method for quadratic factor, computer algorithm for these methods as well. In unit 2 we have to start with, we had started with interpolations and curve fitting, in that we had done your algorithms and error analysis of Lagrangian, the Newton's divide and differences, interpolation, relationship in the various differences operator, piecewise linear interpolation, cubic spline interpolation, Nash spline, Chebyshev's polynomial, approximation, and cause economization of the power series. In curve fitting we have to cover up linear and nonlinear least square approximation, third conditioning in the least square methods, gram schematic process of orthogonization, computer algorithm of the least square curve fitting. In unit 3 we have to cover up the differentiation and integration, where we have to cover up the method based on the integration, interpolations and finite differences, their charts and extrapolation. In integration we have to cover up the error analysis and the trapezoidal Simpson method, Newton's Cotes integration method, Gaussian integration method, Gauss-Legrand method, Lobato integration method, Radau integration method, error terms in pertaining in the integration method as well. And in unit 4 we have to cover up the solutions of the simultaneous linear algebraic equation, where we have to cover up the Gauss elimination method, condition system, condition number, successive and over the relaxation number, date of the conversion, solution of the ordinary differential equation. We have to cover the simple step method, Angikota second order, third order, fourth order method, multiple step method, predictor and corrector method as well. In statistical technique, we have to cover the statistical hypothesis, test of hypothesis, type 1 and type 2 errors, levels of significance, test involving the normal distribution as well. So here we're gonna end up with, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many and maximum people can get the information at once, and you can also enjoy the video as well. Thank you. Hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Thank you.